This video presents LINK-WellOpt, the new Patrol plugin released by Kelleher & Associates Incorporated in September 2016. LINK-WellOpt is a new Patrol plugin that can be accessed either from the process pane or from the simulation ribbon menu. The main purpose of LINK-WellOpt is to optimize the process of choosing the optimal well locations in order to maximize production performance. The optimization is done by evaluating the drainage volume from each well, followed by flow rate estimation to get recovery. You can see in the movie how the volume connected to a particular well evolves through time. LINK-WellOpt is capable of handling multiple million grid models of complex structure with faulted corner point gridding, heterogeneous and general well architecture. What is the technology behind LINK-WellOpt? LINK-WellOpt utilizes a novel approach to compute and visualize pressure wave propagation and well drainage volumes. The technology is based upon the fast marching method, or FMM, and a semi-analytic approximation of pressure and rate transients. As shown in this slide, the FMM is capable of generating a map that is similar to the pressure wave propagation. The beauty of FMM is that it generates a propagation map very quickly. This technique works particularly well in capturing the primary depletion phenomenon. How does the program optimize the well locations? The main task is to compare the cumulative recovery for all well combinations, for all models, and provide the statistics of the ranking for all these well combinations and realizations. The process to calculate the cumulative recovery is shown in this slide. Once the user is finished with the modeling process in the fine or coarse scale, the program will calculate the propagation time map using FMM based on a set of predetermined well locations and combinations set by the user. These maps are then used to calculate the drainage volume and well flow rate using a semi-analytic pressure and rate approximation. Knowing the flow rate from each well, the cumulative recovery is calculated for each case. When running LINK-WellOpt, the user can choose between three application modes, namely Optimize Well, Ranking Realizations, and Multi-Well and Realizations Analysis. The Optimize Well mode determines the optimal number of wells. Ranking Realizations performs the necessary analysis to determine the P10, P50, and P90 of all realizations for a fixed well combination. Multi-Well and Realizations Analysis performs the analysis for multiple well combinations with multiple realizations. The input that is needed by the program can be classified into two categories. The first one is common information. This includes well-related information such as location, perforation, schedule, and possible combinations, grid geometry information, and rock and fluid compressibility and viscosity. The second group is related to the reservoir model realization. This includes the 3D properties such as porosity and permeability, as well as the optional properties of rock type, saturation, transmissibilities, and pore volume multiplier, and net to gross. Users can put as many models as they would like to evaluate and rank. For each rock type in the model, corresponding relative permeability curves are needed. The last input needed by the program is the model for fault transmissibilities. A default value of 1 will be assumed by the program if the user does not modify each fault transmissibility. LINK-WellOpt provides three different output categories. The first category, as shown in this slide, is a statistical output. The user can select whether to see a scatter plot or a box and whisker plot. The left figure shows the scatter plot to determine the optimum number of wells, which occurs when the cumulative recovery reaches a plateau. The figure on the right shows the box and whisker plot that indicates the uncertainty range of the case being run. This slide shows the result for the second application mode, ranking of realizations. In this case, multiple realizations are executed against one single well combination only. The left figure shows the uncertainty with respect to the well combination, whereas the right figure shows the scatter plot that gives the P10, P50, and P90 from all realizations. This slide is the result of the third mode of application, which is for multi-well and multi-realization analysis. The right figure shows the scatter plots of recovery for different realizations. The P10, P50, and P90 models are identified by the program. Meanwhile, the left figure shows the box and whisker plots with respect to well combinations. This slide shows the result for the same case as the one shown in the previous slide, except that the box and whisker plot is selected when viewing the ranking with respect to the realizations. The second category of the output is the visualization output. Three different outputs, namely propagation time, drainage volume, and grid cell contribution, are available. The user needs to select the model and well combination as well as the maximum production time at which they would like to see the three outputs. Any model and well combination can be selected, including the P10, P50, and P90 models that were identified previously. The output can be viewed as an animated movie. The third category of the output that LINK-WellOpt produces is the table of well productivity as a function of time. The table is written as a text file. The text file can be used for further analysis. The ranking result of LINK-WellOpt has been validated against the ranking generated by using a conventional finite difference simulator for different case studies. The comparison shows a consistent linear relationship with high correlation coefficient. The added value of LINK-WellOpt becomes more pronounced when the computational time is considered. LINK-WellOpt performs the overall ranking calculation in a fraction of the time that it will take if a finite difference simulator was used. Furthermore, the time performance of a LINK-WellOpt is linearly related to grid size of the model, as opposed to a square relationship. This concludes our video. We would like to thank you for spending the time to watch it. We also would like to mention that Kelcar & Associates Incorporated has released 3 plugins in the past, namely Connect Upgrid, Transmod, and DynoRank. It is important to note that LINK-WellOpt is replacing the Connect DynoRank program. Existing users should consider upgrading to LINK-WellOpt in order to continue taking advantage of the fast dynamic ranking application. This year, in addition to LINK-WellOpt, Kelcar & Associates Incorporated also released another plugin, Connect Per Match, that provides an improvement on the permeability model by incorporating the engineering test data to the model. To contact us, you can send us an email, a call, or visit our website shown in this slide. Once again, thank you for your attention. We appreciate you taking the time to watch this video.